Hi guys, good evening. So today we are going to discuss about the manufacturing of composites. See, why we are going for composite material? There are millions of materials are available in the world. Why we are particularly going for composite material? Generally, nowadays we require the material which is lighter than the bamboos and stronger than the steel or aluminium. Yes, the composite having the property high strength to weight ratio, high strength to less weight ratio. See, so their lightness is very important in automobiles and aircraft. For example, where less weight means you have the better fuel efficiency. So the people needs the composite materials nowadays. Definition. So two or more chemically distinct materials which when combined have the improved properties over the individual materials. Two or more chemically distinct, that is very important, two or more chemically distinct material, okay, which give a improved property over the individual material. So in the case of alloys, once it is been casted, for example aluminum alloys or magnesium alloys, they don't retain their identities, they don't retain their identities. See, in the case of composites, they retain their identity even though they merge completely into each other. That is one of the major advantage of the composite materials. So the major applications includes the aircraft and aerospace applications, automobile applications, marine applications, sporting industry, biomaterials, and industrial applications. See, for example, in the aviation industries, so everyone know about the Boeing, right? So the Boeing 787, the body construction is made up of 50 percentage of composite materials. So imagine 50 percentage of the entire materials is composite material over here. Okay. So in the case of automotive industry, so in the automotive industry, you can see the Formula One car. See, the Formula One car is made up of carbon fiber composites. Our commercial vehicles, all the vehicles, our commercial vehicles are using fiber reinforced plastics for the body for low weight and high strength. So other than that, the doors, biodental implants, your baseball bat, what you are using in the sports, hockey bats, tennis rackets, shuttle rackets, everything are made up of composite materials. Shoes and your cycles are nowadays, it finds it wide applications everywhere, the composite materials. The major components of the composite materials. See, there are two major phases in composite materials. One is the primary phase, another one is the secondary phase. The primary phase is the matrix. The primary phase is the matrix and secondary phase is the reinforcement. So classification based on the reinforcement. See, in the composites are generally classified in terms of reinforcement. Particle reinforced composites, fiber reinforced composites, structural reinforced composites. Okay. So again, the fiber reinforced composites are again subdivided into continuous and discontinuous fiber reinforced composites. See, in this picture you can able to see the particle reinforced composites, right? So this is a particle reinforced composite and this one is the fiber reinforced composite. So it is a small particles and this is a big particle reinforced composites over here. And here it is a discontinuous fiber and this is a continuous fiber reinforced composites. Continuous, this is a continuous fiber, this is a discontinuous fiber. Okay. So next the classification based on the matrix. So generally based on the matrix also it's been subdivided into three categories: polymer matrix, metal matrix and ceramic matrix. Most of the time we'll be using the polymer matrix with the help of the thermoset, thermoplastic and rubber. Usually we are using the epoxy resin for polymer matrix composites. Okay. The matrix used is a resin. Okay. Let's enter into the manufacturing of composite. There are 5 different methods are available: hand layup method, spray layup method, compression molding, filament winding, and the pultrusion method. See, wet or hand layup method. So the first, you can see in the animation, First the fibers are put into the place in the mold. See, this is the red color, you can able to see the red color, right? So the fibers are first put into the place in the mold. The fibers are then in the form of either in the form of woven, knitted, stitched or bonded fabrics. Then the resin is impregnated. See, you can see the resin is then impregnated. The impregnated resin is done by using the roller. You can able to see the roller also. So once the resin is poured over the fiber, you have to impregnate using the roller, okay, to avoid the blowholes. So the impregnation help in forcing the resin inside the fiber. Yes, see, using the hand roller we are doing the impregnation. Okay, so the laminates fabricated by this process are then allowed for curing. Okay, so next method, spray layup method. Here the fibers are chopped into small pieces and then it will be filled in the spray gun. So this is the spray gun. So other processes are similar. Okay, first you have to pour the epoxy here. After that you have to spray the fiber, chopped fiber through the spraying gun, and then it is allowed to cure. Okay, so next method is a compression molding method. So compression molding method is a widely used method in automobile and aviation industries because we require high strength products, right? So we have to go for the compression molding process than the hand lathe method. So it is a very well known technique. See, so it has already people know about it. It have the upper mold plate and lower mold plate. See, this is the component to be molded. Okay, so not only that, the important factor is here in the compression molder, base plate is stationary and the upper plate is movable. Okay, so then the material is placed between the molding plates, flows due to the application of the both pressure and heat. The material placed in between the molding plate flows due to the application of pressure and heat, and it acquires the shape of the mold cavity with a very high accuracy. Okay, so filament winding process. So in the filament winding process, it is actually an automated process. It is used to manufacture the hollow pipes. It is used to manufacture hollow pipes. You can see very clearly the carbon fiber creel here. The carbon fiber creel. From the carbon fiber creel, the fibers are allowed to pass through the resin bath. Okay. Once it is passed through the resin bath, then it is allowed to wound on the rotating mandrel in zigzag manner. In zigzag manner. Okay. So once the mandrel continuous rotation of the mandrel, so we can remove the hollow pipes using the filament winding process. Pultrusion process. See, it is similar to the winding process. It is used to manufacture small billets. It is used to manufacture the billets. See, the raw materials is fiber over here. The raw materials are fiber over here. The fibers are allowed to pass through the material guide. This is the material guide. So once the material guide passes through the material guide, then it is sent through the pressurized resin. Okay, so the fiber passed through the pressurized resin and then it will pass through the heated die. Okay, then the fiber wetted with resin are pulled through the heated die. The die plays an important role like completing the impregnation and controlling the resin movement. So once the thing has been done, it has been cut into, see here, using the cutting saw, it has been cut into small billets. Okay, here it is very clear: unidirectional glass, continuous strand, resin bath, surface well, performer, heated die, pulling device, and finally cut off saw. These are all the process of pultrusion. So further the material is cured to the final shape, and the die shape used in this process is nothing the replica of the final product, whatever it might be, either in the form of a billet or in the form of wires, whatever it may be. Okay, thank you.